Hello everyone and welcome to my P52 lesson for re-entry. So I'm currently in orbit around the moon and we are going to go ahead and perform a task called the P52 IMU realignment. This is basically to make sure that our platform shows the attitude that it should have. So there's no drift errors or accumulation errors that kind of happens over time on the IMUs. So if I now go into the cockpit, you can see that the FDI is now showing me the attitudes of my spacecraft relative to something. And that something could vary depending on where you are in the mission. This is basically the reference attitude of the spacecraft. And this can be reconfigured over the mission to basically anything that you would need. And in some cases, you might want to align it with the current burn direction, or you want to align it with a location on a planet, or a location and attitude based on a specific time in orbit. For now, we are going to make sure that this attitude is actually correct. So we're not gonna change our refs mat, which is basically our reference platform, the orientation, the reference orientation of the spacecraft, but we're going to eliminate gyro drift that happens over time. So the more that you use this attitude indicator here, you rotate the spacecraft, the gyros will drift and accumulate some errors over time. And this needs to be removed at certain intervals during a mission. I've just done the procedure, so it should be 0 or very close to 0. So the first thing that you want to do is to make sure that the seats are gone and that you're working in kind of an orbital configuration. This can be done by doing the toggle seats. You can see that if I toggle them on, you can see them. And then hit toggle again, and they are removed. Second thing you want to do is to move down into the lower equipment bay where the optics are stored. And you can see them now in front of you. These optics, there's basically two scopes, are used to align the IMUs. And then there's a couple of interesting checklists here. The first one is in the AGC section, you have a star list. And the star list basically shows names of different stars and an index. All of these stars are stored in the memory of the AGC, and these are the only stars that you can use to realign your IMU. So we're going to use this as a reference. Secondly, if you go into map, it's always good to have a good understanding of how the stars are located relative to each other and learn kind of the major ones through constellations and things like that. And lastly, if you scroll all the way down on the command module tab, you will find the GNN, Guidance and Navigation Alignments section, and it has a checklist for P52. This is my main checklist. However, it's a very complicated checklist with a lot of back and forth and branching. So I've created this simplified checklist, which acts like a tutorial that you can actually run using the run feature to perform the desired action. The one that we are going to do today is to realign the IMU, that's the refs mat, but I'll be using the real checklist for this one and not one of the helpers. So I'm going to click that. The first thing is that it's asking me to do some setup. You are going to have the CMC on, which is it, and I have the ISS on as well, and the orientation is known. And then we are going to run P52. You can use the disk key down here, verb 37, enter 52, enter. And it's going to take a couple of seconds on loading everything up. And then it's going to show me a selection here. So the first thing here is that verb 04 now 06 It's showing option code 1 in register 1 and then an option in register 2. And this is the one that we're interested in modifying. I can accept the default value, which is 0, or I can reject it. 0 is not a real option, so I'm going to reject that. So I'm going to say verb 22, enter, and you can see that it blanks out. And the one that I'm interested in is option number 3. So you have a couple of options here. Preferred, this is to align the IMUs with the burn direction after you've been going through P30 and the SBS burn planner. Then you can align the IMU with the burn direction. So you know that you are burning in the correct direction if you center the F die, basically 0, 0, 0. The nominal is the local vertical at the specified mission time. And then you have refsmat, which is the one that we're going to do now. And then lastly, the landing site, which can align the IMU based on a location on a planet. This one isn't currently implemented manually yet, but it's an automatic thing in reentry. But I'll add support for this later. Okay, so we are going to now enter option 3, and then enter. And then we are going to hit proceed. So I'm currently on step 2, and it says there here that if the option is 3 and I hit proceed, then I need to go to step 8. Proceed, step 8. So this is 3, 4, 5, 6, 7, and 8. To be able to use the scopes, you can simply just click on the one that you're interested in. So I'm going to start with the scanning scope. This is basically the telescope, and it shows me a 60-degree field of view. The other one is the sextant, which has, I think, what's 1.8 degree of view, so it's very zoomed in. It's very hard to navigate the night sky with this one. So usually you will want to do the scanning telescope for this. So this is the SXT, which is this sextant. Then you can switch between those two using this arrow for simplicity. And you can move this one using the control and arrow keys to pitch up and down and things like that. Keep in mind that you will need to set the mode to manual or CMC. Manual is where you have manual control, just like I did. So set this one to manual. I've set the speed to medium for now. And then you will need to make sure that the telescope is slaved to the sextant, so that when you move the sextant using control and the arrow keys, you also move the telescope as well. So now they two basically move equally using the arrow keys. Right, so this one is asking me to start acquiring the stars, and the AGC knows the orientation of the spacecraft based on the current IMU and the direction of the scope. So it can now provide me a couple of suggestions on stars that I want to mark. So I'm going to hit Pro on that one. And then it's showing noun 70 with a target code of 15. This is the AGC is now suggesting me to mark star number 15. And if I now go out here and I can move the scope around, you can see that there's some normal looking stars, and then there's a couple of bigger one which is having this blue halo around them. That blue halo indicates that this is a star that's part of our list. And this one is Sirius, which is index number 15, which is the first star that the computer wants me to mark. And why does the computer really care about these stars? Why are they actually used to align the IMUs? Well, the stars are basically fixed points in space. And we know from textbooks, basically, that there's a known angle between each of the stars that exists. The AGC has this knowledge stored in it. So let's take, for example, star number 15 and star number 16. Let's pretend that the angle between those two are 12.93 degrees. Then we can form markings using our scopes to say that currently this star is in this direction. And then you mark the other star, and this star is in that direction. You will get the angle between those two markings. First of all, those two markings should then be very close to the textbook angle that we know that they should be. And if they are, we know that our marking has been done, and we can align our IMUs relative to those markings. And if the spacecraft then detects that there's differences between where you said the stars are versus where the spacecraft thought it was, then it can torque the gyros to move into the more correct or the corrected position. So currently, it's now waiting for me to let the computer know which star I'm going to mark. It's suggesting 15 based on where I was looking, and I'm happy with the result. So I'm just going to hit Pro on that. And then verb 51 is flashing. An important remark is that even though the AGC is expecting me to mark star number 15, you don't actually have to do that. You can tell the computer later what star you actually marked, so it doesn't really matter what it suggests. But it's a good indication. So I hit Pro, and scroll all the way down. Then it's saying that if you're in manual mode, go to 12, and we are in manual mode based on this, or 11 if it was in CMC. So now I'm going to scroll down to step 12. That's 11. That's step 12. And as you can see, it's showing verb 51, which means please mark. Then you need to center the target in the sextant and then hit mark on the UI here. So there's also a hotkey that you can bind to mark as well if you want to. So now I'm going to go back into the scope. Since I'm in orbit around the moon, this spacecraft will rotate slightly all the time, as well as a spacecraft really never stands 100% still in space. There's always going to be some attitude rates. So that's 15. And I'm going to switch to the sextant, and I'm going to get a good mark on this one. Try to mark precisely on top of the star itself and look away from this blue halo. This is just a helper. I'm going to hit mark. You can also set, there we go, mark. You can also set the speed to slow to make it easier to track a star. All right, I've now marked the star. So if I now follow along with the checklist, it's now asking me to go to 15, which is verb 15 on 25, asking me to terminate marks. Am I happy with the results? I did mark the star, so yes, I'm happy. This basically means that, okay, I'm ready to proceed. I've marked. And then I'm going to hit Pro. And then 71 wants me to kind of verify what star I actually marked. It suggested 15, but if you did mark a different star than 15, then you should tell the AGC on this step. So now I'm just going to find this one here. This is step number 16, noun 71, target code 15, which is the one that I marked. This is for planets only. There we go. Okay, and then I'm going to hit Pro. Then it's now returning to noun 70. Let me just double check here. Return to 9 for target 2. So then I'm going to return back to step number 9, which is verb 1 noun 70, which we can see now. And it's saying me to mark star number 12. Then I'm going to accept that if I'm in P52, which I am. So then I'm going to hit Pro. Now we're at V51 again. Let me just move the checklist down there. So I'm still on manual. That's 12. And this is basically just a repeat of what we just did earlier for the previous mark. 51 is flashing. Let's find star number 12. And it's going to be one of the stars. Let's see. There we have 12. So then I'm going to go to the optics. And then I'm still going to do the waiting game here because I have medium speed. And mark. Right. And go to 15. Verb 50, noun 25. Terminate marks. I'm done. The star that I marked was star number 12. So let's see, Pro. And now verb 0605. Let's see. We are now going to skip this one because we already marked target 2. We're not doing any planets. So we're now seeing that step 18, verb 06 now 05. It's showing me a sighting angle differences. It's the first 3 digits are your angle in degrees, and then you have the fraction on the 2 last numbers here. So my difference between my markings and the marking differences that our textbooks show are now 0 degrees difference, which is pretty good. I think the limit for me to be able to accept this is 0.03. So if you have 3 on the last digit here or less, then you're good to proceed with your results. If you have it above, you will need to redo the procedure. So make sure that your markings are very precise when you hit that mark button. Right, so I'm going to hit Pro. And now it's showing me how much difference my gyros are based on my markings versus what it thinks it is. And I have 0 difference, which means that we're all good. And I can go ahead and proceed with the torquing. It's not going to torque because it's all 0. But if it were something else, then it would have just zeroed these values by torquing. So I'm going to hit Pro and Pro. And then it's going to want me to perform a fine line check, which is basically, I think, redo the entire procedure to verify. But I'm going to reject that, and so can you. So just hit Enter. And we should return to program 0. And that's it. Now we've aligned the IMU, or realigned the IMU by torquing them to the correct attitude versus what the spacecraft thought it had based on accumulations in the gyros. thank you everyone for watching, and I hope you have some use of this video. I know that I've received quite a lot of questions on this. If not, just reach out and let me know, and I can remake this video, or I can answer your questions on Discord, things like that. All right, thanks again.